So good evening, everyone, and a very warm welcome to the final day of our national webinar series, Innovating Skills and Learning for Mathematics Educators, jointly organized by CALL SEMCA and the Delhi Association of Mathematics Teachers, DAMT. Over the past 2 days sessions, we have explored AI integration in mathematics with Professor P.K. Chaurasia and competency-based assessment in mathematics with Professor Jyoti Sharma. Today, on the third day, we conclude the series with a focus on Olympiad level mathematical thinking
Excuse
by
me,
Professor Shanta Laishram.
excuse me.
Yes, sir.
Good evening, Mr. Khalid.
Yes, sir. Good evening.
I'm asking, the previous two sessions, we have got so many useful information. So, can we get a recording or some, you
Sir,
know,
we'll share these details in the end. You can put the questions in the chat box. Thank you so
yeah,
much.
okay, fine, fine.
As this series now becomes to its concluding day, it's my privilege to invite our director, Dr. B. Shadrach, who has joined us today, to share his message with the participants and mark this important occasion. Dr. B. Shadrach, sir, over to you.
Thank you, Khalid. First of all, my gratitude to Professor Shanta Laishram, who is our expert and resource person today, who is going to discuss with us the aspects around the International Mathematics Olympiad. Although we've started this off as an initial pilot, we are really overwhelmed with the response that we have received. All the three webinars, including today, have been fairly well accepted by the teachers. I am informed that the first webinar had close to 1,060 participants, whereas the second webinar the previous day was attended to by almost 1,100 participants. And today also we are expecting a good number of participants. So I would only hope that this is just the beginning of a series of similar webinars. The Commonwealth Education Media Center for Asia would coordinate. This time we focused on the subject mathematics, but we may, in the short run, look at other subjects such as physics, chemistry, and including humanities and other social science certificates, subjects as well. And today's webinar is of importance and significance because, the teachers can do much more than preparing students with the help of the textbooks that are at their disposal. Now at the 9th and 10th standard level, we do use, a majority of us use NCERT textbooks alone, and we make it easier for our students to prepare for the examinations. But I think webinars such as these, handled by Professor Shanta Laishram and others, would enable us to go beyond the textbooks, particularly to identify and nurture talent within our classrooms, where gifted students and even every single student could prepare for a path where one could think about problem solving techniques, look at numerous creative strategies. These Olympiads also enable us to analyze the mistakes that we are making in terms of gaining a conceptual understanding of our strengths and weaknesses, particularly in the foundational issues in subjects like mathematics. And finally, we also believe that teachers would play a very important role in providing the right resources, particularly for students to manage their time when it comes to appearing for tests and competitive exams of this kind, but also cultivate that winning mindset. Everyone is a winner when it comes to these types of international mathematics, Olympiads, and others. But that said, the idea of excelling in such competitive environments is sometimes equally helpful. And it's also the beauty of mathematics, where we are able to demonstrate our special qualities and values. So I'm very thankful to Professor Laishram and also Dr. Srivatsava, who has been guiding and mentoring us at SEMCA, and to Mr. Khalid for coordinating the entire effort. And more than anything, I'm grateful to the thousands of mathematics teachers who are dedicating their evening, one precious hour of their time, to come together to join these cohorts of learning to continue to progress in their professional life. So I assure that Call Semka would continue to stand with you in your professional growth and professional journey. But more than that, we would like to be your allies and friends, cheerleaders, in encouraging you in whatever you do in your professional life as well as in the personal life. I would encourage you to subscribe to the SEMCA news updates, which we release every month, which would give you an idea of what kind of programs that we offer, but also join any such future events as and when these are announced. So thank you again and all the very best.
Thank you very much, Dr. Shadrach, for your words of encouragement. Now, to continue the proceedings, I'm pleased to invite Dr. Srivatsava, the senior mathematics subject expert and consultant at SEMCA, to share his reflection and also to introduce today's distinguished speaker, Dr. Ramesh Chandra Srivatsava. Sir, over to you. Sir, I think your mic is turned off. Ramesh, sir, are you able to turn on your mic? Sir, you're not audible. Your mic is turned off. Sir, your mic is turned off. It's my privilege to introduce our expert for the day 3, Professor Shanta Laishram, Professor of Mathematics at the Indian Statistical Institute, ISI, New Delhi. Professor Laishram is a leading researcher in the field of number theory and discrete mathematics and has also contributed extensively to mathematical research and international Olympiad training in India. He has been closely associated with the Mathematical Olympiad program in the country, mentoring and guiding talented young mathematicians at national and international levels. His work not only advances the frontiers of pure mathematics, but also inspires innovative approaches to teaching and nurturing mathematical talent. Today, he will be speaking on the theme of Olympiad level Olympiad level mathematical thinking, sharing his experience and insights on cultivating higher order mathematical thinking among the teachers and students. Now it's my privilege to invite Professor Shanta Laishram to proceed with the session.
Yeah, thank you very much, Khalid, for your kind introduction. So first of all, I'd like to thank the SEMCA, particularly Director Dr. Shadrach, then Dr. Ramesh Chandra and others for the kind invitation. So today I'll be presenting about this International Mathematical Olympiad and introduce you to some of the important aspects of mathematics which is necessary for the Olympiad, and talk about also trying to bring in, show you how the problems of this Olympiads look like, how thinking, what kind of thinking you need. So I'll share my screen. So let me share my screen. Okay, so just a second. Yeah, can you all see my screen?
Yes, sir, we can see your screen.
Oh, okay. So I'll start with what is International Mathematical Olympiad. I'll just give a brief glimpse of this, the International Mathematical Olympiads, then talk about different aspects and how do so what actually happens there, and talk about the kind of problems we expect in the Olympiads. Let me start my talk. So actually, International Mathematical Olympiad is a contest for high school students and is one of the oldest international science Olympiads, and it's the most prestigious among all the mathematical competitions for high school students. It started in 1959. This year, it was the 66th IMO, which was hosted by the Australian Met Trust at Queensland, Australia during 10 to 20 July. And in fact, I was a leader for the Indian team this year. So this is the logo for the International Mathematical Olympiads. And of course, I just want to show you first few pictures. So this was the logo for this IMO in Sunshine Coast, Australia this year, where I was the leader for the Indian team. So this, I've not so many pictures, but just wanted to show you, like this was a team from India, like me, then deputy leader, then 2 observers who were involved in the Olympiad activities. And this is the team, of course, this is the team from India who got 3 golds, 2 silvers and 1 bronze in the IMO this year. And of course, I'm not going to read out the names. It's all available online. Later on, I'm going to share my slides so you can all see the list. And basically, what happens in IMO is that every country can send a team of up to 6 participants along with a team leader, deputy leader, and observers. And more than 100 countries which represent more than 90% of the world's population participate in IMO. This year, around 120 countries participated. So there's like the International Olympics Committee, there's a board called IMO Board, International Maths Olympiad Board, which is responsible for all the, logistics and all academic aspects for this IMO, along with the host country. So next year, the IMO is going to be in China during 10 to 20 July 26. And India was hosted the 37 IMO in 1996. Usually it's held in July every year. So basically, what is actually IMO? So what happens in IMO? So this is just a 2-day contest, which consists of 6 problems. On the first day, you have to solve 3 problems in 4.5 hours. And next day, you have to solve 3 problems in 4.5 hours. So each problem is worth 7 points, and every contestant can get a maximum of 42 points. Though, like every country sends a team of 6, everyone writes as a single, they don't write it as a together. It's like a single person writing the exam. So the problems are chosen from various areas of high school mathematics, which are broadly classified as algebra, combinatorics, geometry, and number theory. Actually, the principle of this IMO problems is that anyone with a basic understanding of mathematics should be able to understand the problems, and solutions, however difficult, maybe however difficult, but there should be at least one solution within using high school mathematical ideas without using calculus or higher mathematics. Of course, the problems can be really very difficult, and we don't assume any knowledge of calculus or real analysis to solve the problems. However, if the students know, they can assume those results, but one can always solve the problems without doing that. And there cannot be any problem which relies completely on calculus, etc. And so basically, there should be a solution completely elementary in the sense that within the high school mathematics. Basically, the aim of problems is to So what is the aim of this IMO? Problem selection. So basically, you have to find elegant, very beautiful, deceptively simple looking problems, however, which requires a certain level of ingenuity, or sometimes a great deal of ingenuity to solve the problem. So to get 7 points, you have to really have very ingenious ideas or concepts. And like you see, there's 6 problems, and these problems are largely designed to require creativity and ability to solve problems quickly. So how the problems in IMO are selected? So every year, like except the host country, so they any other country, participating country, can submit suggested problems. They can submit a number of problems. Then host country forms a problem selection committee, which shortlist this a list. I mean, from the suggested problem, they make a shortlist. So usually they may do it around 2 weeks before the IMO happens. Then problem selection committee typically selects around 6 to 8 problems, is in algebra, is in number theory, combinatorics, and geometry. So around 40 to 48 problems they select. And shortlisted problems are given to the leaders of the teams when they arrive at IMO. So basically, when we go to IMO, the leader first goes and the team comes later. So IMO's jury is the highest decision-making body during IMO, which is composed of the leaders of all participating countries. And this is responsible for all decisions related to IMO, and more importantly, selection of 6 problems which appeared in the contest. Then the marking scheme, the cutoff for medals. So what will be the cutoff for the medals, like for silver, gold, bronze, etc., and any other decisions. Of course, like sometimes jury meetings can be very long, even extending till midnight. So from the shortlisted problems, IMO jury selects this 6 problems in the order P1, P4, P2, P5, P3, P6. You may see that this is not numbered consecutively. Basically, P1 is supposed to be the easiest, P6 is supposed to be the most difficult, and P1, P4, P2, P1, P2, P3 are the problems for the first day. And in the increasing order of difficulty, P1 is easiest, then P4, then P2, then P5, P3, and P6. So the way we select, one selects these problems are such that P1 should be solvable by, in principle, by most of the contestants, whereas P6 should be so difficult, should be most difficult among all the problems, and should be, solvable by only a very few contestants. So for example, this year, the 6th problem was actually only, among around 1,200 contestants, only around 20 students were able to solve the 6 problems. The 6th problem. So yeah, I'm not going to go into this, how the problems are selected. After a lot of discussions and making sure that no problems has appeared before, and every country tried to sort of select the problems where their candidates or contestants can get more points. So there are a lot of discussions happen, but finally you select the 6 problems just before the team arrives to the contest. So this is the sort of schedule for this year in IMO. Basically, right now I'm not coming to the mathematics part, I'm just showing you the technical part. So 9 July, the 9th and July leaders arrived, then so-called coordinators arrived, then contest was only 5th. And after the contest, it's the role of the leaders and deputy leaders to sort of assess the solutions written by contest to get points. How among 7 points, how much points they get, etc. Since like 2 days after contest is really crucial, so that every contest the contestant can, we try to get contestant whatever possible they can get. So what IMO is different from other contests is that in IMO, even if the solution is not correct, you can get points. If you have written it in the rough work, if you have done it correctly, or you have right ideas, even if you have done, if there's some mistake in the solutions, you can get full points by looking at the rough work. So basically, how you think, how you attack the problem, how you proceed, that really plays an important role. So in this regard, the leader and deputy leader plays an important role to sort of understand how the students are writing the exam, and somehow we have to sort of really think, really sort of try to get points for the contestants. So these are some kind of this thing. So yeah, so basically what happened is that you see there are 6 problems and every problem carries 7 points. So they are altogether 42 points. So depending on how many people, how many points a candidate scores, they will be given gold, silver, bronze. So the idea is that the gold, silver, bronze are, I mean, only given to the at most half of the total number of contestants. So that's why even a lot of countries or leaders and deputy leaders try to get extra 1 point, I mean, as many possible points for their contestants. Sometimes we spend hours just trying to sort of discuss with the coordinators, problem coordinators, to get points for the contestants. And this year, if out of 32, 42, the 35, if you get 35 and above, they got gold, 28 and above till 34 silver, and 18 and above to 27, they were given bronze medals. So those who don't got below 18, but they secure 7 points in one problem, like one problem completely correctly, they were given something called honorable mentions. So in fact, we spent just before the announcement of the result, we spent till the midnight to finalize the cutoff. So this is sort of the ranking for this year. Of course, China ranked first among around 120 countries. India was ranked actually 6th, in the sense that China, then USA, then Korea, Japan and Poland, they were tied at fourth place. Israel was at 5th place, and India was at 6th place. So, but country-wise, we were sort of set at 7th place, though actually it was 6th place. And so IMO, actually, this has become very important in recent years. And they also maintain a list of something called Hall of Fame, where they mention, they sort of listed people who have done really well in the IMOs in the recent, I mean, many years. For example, there's this one candidate called Zuo Kun, a song from Canada. He participated in 6 IMOs. He got 5 golds in among the 6, 1 bronze. And similarly, like for example, there's one student from India. He participated in 4 IMOs. He got 3 golds and 1 silver. So these are called Hall of Fame. And also, all of you know, of course, that in mathematics there's no Nobel Prize. So the highest prize in mathematics sort of is considered, highest considered prize is called Fields Medal, which is given to 40 years of age. And some of the Fields Medal winners in the past have been IMO contestants. For example, Terence Tao, Gregory Perelman, Ngo Bao Chao, Mariam Mirzakhani, on whose name International Mathematics Women's Day is celebrated, or Akshay Venkatesh, Indian origin, who is now in Princeton, or Peter Scholes, Marina Biaskova. They are all Olympiad medalists. So these are all about the IMO. Now I want to tell you about this. So how, I mean, of course, this how I mean, India sends a team, or how students can participate in the Indian team. So for India, the Homiva Center for Science Education, under this the TIFR, which so they're responsible for Maths Olympiad program in India, and is funded by NPHM, Department of Atomic Energy, National Board for Higher Mathematics. So currently the national coordinator is Prithviraj Dey from Homiva Center, and India is divided into around 30 different regions, which includes Navodaya Vidyalayas, Kendriya Vidyalaya as separate regions, and each region is assigned a regional coordinator. So I'm showing you the different stages of Olympiad last year. Last year we just finished this year, but next cycle for cycle for next year is already started. So Olympiad has different stages. Start with IOQM. Though it's 24 now, IOQM 25 just had this exam in the last Sunday. Basically, the second level was last Sunday. Had this exam on last Sunday. So IOQM is the first stage where all the students write the exam. Then after that, they're selected to participate in this called RMO, Regional Maths Olympiad. Those who are selected, shortlisted to write the INMO, they're given this some training camp called INMO training camp. Then they write the INMO, International Mathematical Olympiad exam, which is stage 3. So stage 1 is stage 2 is RMO, stage 3 is INMO. Then after that, they come to IMO training camp, where we selected team of 6 contestants to represent India. Then after that, they are sent to the IMO. So this is how different stages of Olympiad program happens in India. So basically, there are 4 stages before coming to IMO. IOQM the first stage, RMO, INMO, IMO training camp, and then go to IMO. So the first stage is called IOQM, which is a 3-hour exam consisting of 100 marks. And so this is not a descriptive, it's kind of a objective in the sense that you have to write the answers as 2-digit numbers from 00 to 99. And it's an OMR-based exam without any negative marking. So here there are 2 questions of 2 marks each, 12 questions of 5 marks each, 2 questions of 10 marks each. So I'm going to later on show you some last paper of this IOQM. And so basically, out of this 100, you have to write the answers as 2-digit, and you check it OMR-based exam. And from that, every region, there are some selections, and they write this something called Regional Maths Olympiad, which is a descriptive paper. You solve 6 problems over 4 hours, and each problem carries 17 points. So total mark is 102. And basically here, writing the proof solution is really checked. And from this RMO, students are selected, and they write this INMO exam, which is also 4 hours, 6 problems, like the way IMO contest. So here 6 problems, at least 1 from algebra, 1 from number theory, 1 from combinatorics, 1 from geometry is there. And it carries 17 points. And of course, total mark is 102. So from INMO, people around 45 to 60 students are selected together with the previous batches, and they're called to the training camp, where you select the team for the International Maths Olympiad. So more details, the IOQM is actually managed by something called Mathematics Teachers Association of India, MTA. So more details can be available on the website. So now I come to the syllabus for the Olympiad exam. So as I informed you before, so Olympiad exams doesn't involve calculus, analysis, or higher level of mathematics. So basically, syllabus is within the high school mathematics, or so-called pre-college mathematics. And of course, broadly divided into areas of algebra, combinatorics, geometry, and number theory. And like, for example, areas cover can be arithmetic of integers, geometry, quadratic equations and expressions, trigonometry, coordinate geometry, system of linear equations, permutation and combination, factorization of polynomials, inequalities, elementary combinatorics. So some bit of probability theory and number theory, finite series. So far in India, complex numbers haven't been included. Probability and complex numbers have not been included in Olympiad in India so far, but it's likely to be included soon in the next few years, if not next year. So syllabus, in a sense, is spread over class 11 to 12 levels of students. However, problems in this topic may involve a high level of difficulty and sophistication. Basically, just knowing simple ideas may not be sufficient. So now I'm going to go to the some aspects of Olympiad problems and ideas. So before that, I just want to list you some of the books which may be useful for Olympiads. These are also available on the website of the Homiva Center for Science Olympiads, where they've listed the books, all question papers, everything. So particularly this book called Problem Primer for Olympiads or Challenge and Thrills of Pre-College Mathematics or An Excursion in Mathematics. These are kind of standard. I mean, these are good books to start preparing about Olympiads. And there are many more if you want to do better. Luckily, nowadays, we have a lot of online resources to work about it. And more details about Olympiads, you can actually get it from this website of Homiva Center, olympiads.homivacenter, spcsc.tfr.res.in, or more about International Maths Olympiad from this IMO official website. So these are the sort of technical information about how we can go for these Olympiads. So now what I'm going to do is that I'm going to tell you how one prepares. So why Olympiads is important, and I mean what kind of problems syllabus are there in the Olympiad. In the recent past, Olympiad has become very important for the students. Particularly, it gives a good gateway to a career in mathematics. And like in India, for example, if you're one of these INMO awardees, you can go for direct interviews in BMed program at ISI Bangalore, Bachelor Mathematics program, or BS programs at CMI, in fact, or IIT Mumbai or IIT Kanpur, etc. In fact, some of these IITs like Mumbai and Kanpur, they have been taking students from this INMO awardees. And also, like most of the team members and INMO awardees, is easier for them to get admission to some of the top undergraduate places in the world, like MIT in the US, MIT Cambridge, or Harvard, Oxford, etc. And also from time to time, there is scholarship for them. And in fact, in this current time of this data science and AI, etc., so the people who are very good in Olympiad level activities, because they have a good knack of problem solving activities, which are, but in huge demand by this many of the financial and and other companies, because where you need to do a lot of problem solving. They are very helpful. So now so these are all about the Olympiad and aspects of Olympiads. Before I go to some aspects of mathematics about problems, I want to know if there are any quick questions from anyone.
We welcome you, sir. This is for the first time we have gone into the details how it is being conducted. But till now, we were only looking for how to make our children prepare for this. So,
So fine. I'll be coming to that. So I'll be coming to sort of some of the basics, and I'll show you some of the problems, how one is to think. You see, that part I'm going to come. So now I've just talked about the aspects, more of technical, non-mathematical aspects. Now I'll come to that part from now on. Okay.
But this is also a new thing which we are supposed to know. So thank you for that, sir.
You're
Sir,
welcome.
actually, there was a question, sir. Please share
Yeah.
all 6 problems with solution. I think it is related to the P1, P2, P3, P6 that you mentioned.
Okay,
So the
so
question is, please share all 6 problems with solutions.
Yes.
yeah, so the solutions are actually freely available online. Later on, I'll give you the link. In the IMO website, all the 6 problems are listed. I mean, for last many years, you can actually download for. And so, of course, solutions are not listed there, but I'll also give you some ideas where we can get. Okay, so now let me just come to some of the basics of number theory and combinatorics, and show you how some of this simple looking
Sir?
yeah.
Happy evening, sir. I wanted
Yeah.
to just ask one small question. How can we
Yes.
prepare the same for the primary children? Since they also have mathematical Olympiads, how do we prepare them for them? Can you
Okay.
please address that also, sir?
Okay, yeah. So one thing possibly I missed saying is that Olympiad exams, the official Olympiads, they are only for classes. I mean, 10 to 12 students were very talented, 9 and above students can write. So there's no official Olympiad so far for primary or small children. I mean, the so-called SOF and many other privately run Olympiads, I mean, they're not of, I mean, I don't consider them to be a good standard, and many of them are just for making money. I mean, I believe so, but unfortunately, there's, I mean, like, you see the, okay, so this, unfortunately, there's no sort of very standard exam for the Olympiads, so-called Olympiad level for the smaller students or smaller class students. Only this Olympiad exam, this is only for one exam from 9 to 12. There's no separate exam for 9, 10, 11, 12. This is one single exam where anyone from class 9 to 12 can write, and they have the same paper. But nevertheless, I mean, you're welcome to, I mean, look at the syllabus and you can prepare your children or students for these Olympiads. I mean, nowadays online resources are there. And I think there's some plans for many of the official organizations to start similar Olympiad, I mean, pre-Olympiad kind of contest for students at different levels. Many states have started. So, but I'm not listing them. I'm just talking about the official Olympiad, which is internationally recognized, where India officially sends a team. That's what I'm mentioning. And this is only open to those who are below 12. I mean, those who are studying in class up to class 12. Anyone from younger class to 12, they can appear. But it's only one exam, one question paper, and no separate exam, nothing. And so this is what I want to tell you. So also maybe at the end, I'll tell you some of these resources or some of the places where there's some very, what to say, very important training programs or kind of this Olympiad level, or to say, or trying to understand, trying to find the talented kids. So there's some sort of places like Baskars are partisan under MBHM. They also have this different contest to train the very talented children from class 6 onwards too. I'll mention a bit at the end. Okay, now, I mean, many of you may be familiar with some of the concepts, but I just want to start with like, so some sort of important concepts in mathematics, which are essential for Olympiads. I cannot list all of them because it will take a lot of time. Particularly, I'll focus on combinatorics and number theory, and I'll use them to solve some of the problems and tell you how we think and solve these problems.
Sir,
This
one of
is,
the questions,
yeah.
sorry to interrupt, sir. One of the question was there, if the syllabus is basically based on 11th and 12th standard maths, why do we keep the same set of questions for 9th and 10th students?
No, actually, I mean, so one never says there is 11 to 12. So there's a syllabus which I have mentioned to you here. This arithmetic of integers, geometry, quadratic equation, expressions, trigonometry, coordinate geometry, system of linear equations, permutation, combination. So many times students also learn this in 9-10. Whereas probability and these complex numbers are learned. I mean, so far there's probability and complex.
Excuse me, sir.
Yeah,
This
yes.
permutation, combination, and trigonometry, which is of higher order, along with probability, inequality, complex number, these are all mainly in class 11 and 12. That is the reason we are finding problem that class 9 and 10 children has to be prepared. They are not to be prepared on the basis of class 9 and 10 syllabus only. We must have for the senior classes, and it would not be just one class higher to them. It would be up to class 12.
Yeah, I agree. So basically, this is the kind of syllabus proposed by the IMO International Maths Olympiad. It's not, whereas so far this probability and this complex numbers has not been considered as a, I mean, this is the area, I mean, they plan to cover, but so far it has been covered. Only the arithmetic of integers, geometry, permutation, combination, these are, I mean, I understand these are mostly in 11, 12, but the contest is for up to 12 standard, but talented, it doesn't say that 9, 10, I mean, any talented students from 9 to 12 can apply, but it's mainly for 11, 12, but nowadays many students, they prepare and from 9 and, I mean, like very talented 9 and 10 can apply. So unfortunately, or fortunately, this is the sort of a syllabus they have, this is how they have, IMO board has decided for Olympiads. But I understand. So 9 and 12.
And 9 and 10 also having so much of topic from where they can be tested well. Like number itself is a big concept, sir.
Yeah.
And factorization, when we put in a case of polynomial, it is also having a number of questions which can be taken up as an Olympiad test. Why
Yes.
not these are given as a syllabus? Why we are putting extra one? From their own reason, if something is being chosen, it would be better now. They could have the kind of thing that they can explore there.
Yeah. So
Yes, sir.
basically,
Whatever they have in 9th and 10th, in that advance can be asked, right?
Yeah, so basically the idea is that at least 19 students from what they know, I mean, from their learned so that they should be able to do it in a way, I mean, like they need to know these concepts, and they should be with some knowledge, some concepts and ideas, they should be able to actually solve these problems. And it turns out somewhat that most of the in contests, I mean, below 9, 10 students, they're doing much better than 11, 12 somehow. So, but I agree with you. The syllabus has components from 11 and 12, which are
Sir,
not.
good evening, sir. This is
Sir,
Shankar.
sir, we won't be taking any more questions because such
Uh,
questions we can take it in the end.
Only
We
one
can start
question. Only
continuing.
one question.
We'll take it in the end,
Only one.
sir. We'll take it in the end, sir, because our session is also limited with time. So
Okay.
respecting
Actually,
sir's time
related
and
to this,
everything.
I want to ask only one question. Okay.
Yeah.
Okay, this will be the final question. Then we won't be taking any more questions. We'll continue the
Actually,
session.
sir, in 11th syllabus, for example, in binomial theorem, they are given now the syllabus was reduced very little. Only basic concept is there for finding middle term, finding some coefficient terms are all deleted. So CBSEs are continuously giving this for the students. Then how the students will attend some
No.
question.
Yeah, I mean, about that, you see, so the government or the these boards are supposed to take care of, because this is not, you see, this is the syllabus made by the International Maths Olympiad Board. I mean, they're not for India. This is not the syllabus for India. So, and I mean, this is a board for the International Maths. So, I mean, syllabus for the International Maths Olympiad. So, those who want to really write the Olympiad, they have to learn this. Unfortunately, there's no other way out. Otherwise, our students won't get. I mean, the candidates.
Otherwise, we have to take care of the children, and we have to insist the extra classes, and we have to teach them.
And also one thing I have to tell you, the
Why don't
Olympiad is not
the
for.
CBSE implement this again? Because in COVID time they are reduced, but
Yes.
now time has taken already 4 years it happened. Now students are struggling very struggling, sir.
Yeah, actually, it's a
Because
policy. Yeah, maybe I will cut short. I mean, thank you for pointing. It's important. Maybe it's more of a policy decision, which I think at some other forum or
kind of
CBSE
people
can.
like you have to take care of this
Okay.
and move to CBSE to tell
Yeah,
them
sure.
that this is so much of things are reduced. Important concepts are reduced.
Yeah, so I'll also try to connect with CBSE and tell them about this. So hopefully, and
Yes.
also ask
Yes. Thank you so much.
Olympiad committee to write to them also. Okay, thank you.
Thanks for answering this.
Thank you.
Okay.
We won't be taking any more questions, sir. Please continue the session.
So I just want to briefly show you some of the problems because this, I mean, the time is so short that we cannot really go to many problems, but I just want to show you some basic, give you some basic ideas, useful facts, which are useful to solve problems. So one of the first starting point is so-called well-ordering principle, which says that a non-empty subset of positive integers has a smallest element or least element. And the principle of mathematics in the mathematical induction in particular is equivalent to the well-ordering principle. And there's this one very nice simple concept called pigeonhole principle or Dirichlet-Box principle, which tells you that suppose there are, say, n pigeonholes and n plus one or more pigeons fly in, at least one of the pigeons, at least one of the holes will have two pigeons. So this is a very simple concept, but it's very useful, very important in this Olympiad level mathematics, not in that, but in higher level mathematics also is very important. And you just mentioned, one of you mentioned about the binomial theorem. So this binomial coefficient n choose R, this is, there are exactly this n choose R ways of choosing R objects from n objects without ordering. And number of ways of choosing zero, not choosing anyone, zero out of n is one, and you cannot choose more than n out of n, n. So these are some basic useful concepts. And all of you know the concepts of remainders and quotient. Given a and b with integers, with b bigger than 0, there's a quotient. When b divides a, there's a quotient q and remainder r. Or remainder r satisfies, is a number between 0 and strictly less than b. For example, 10 is 1 into 7 plus 3. 3 is the remainder. And GCD, like this is concept of GCD, but there's a special way of writing GCD as that GCD of two numbers can be written as a linear combination ax plus by for some integers xy. So if you are given a and b, GCD of them can be written as x plus by for some x and y. And one of this lemma called Euclid's lemma tells you that if a divides b times c and GCD of a and b is 1, then a will divide c. So these are coming from basic number theory and combinatorics. Another fact is that if you have a product of n numbers which is kth power, like a square, cube, or any kth power, and they are relatively prime, then means any two of them GCD is 1, then every AI is a perfect power. Like product of say two numbers is a square and they are co-prime, then both of them are squares. And another simple fact, which is quite important for many of these problems, is any two consecutive integers are relatively prime. And I don't know, this is whether these are in the school textbook, I need to see, but this greatest integer function or fractional part of numbers are very important. So greatest integer function is the largest integer less than or equal to x. For example, if x is 1.1, greatest integer function is 1. And for a prime p, so the order of prime p dividing m is the highest power of p or exact power of p dividing m. For example, 5 square divides 100. So 2 is the order of 5 in 100. So 5 square divides 100, but 5 cube doesn't divide 100. And given n factorial, we know how to calculate the this power of p dividing n factorial. So this is given by the sum of the greatest integer function n by p square, n by p cube, and so on. It's a finite sum. And so one of the easy problems, like in Iocama, start with asking what is the number of zeros at the end of n factorial. Like if you write n factorial, like 3 factorial or 4 factorial, 5, if you write down, then how many zeros are at the end? They're actually given by the power of 5 in n factorial. These are the very simple concepts coming from number theory. And there's so-called Euler's phi function. This counts the number of integers less than or equal to m and co-prime to m. Or Euler function, Euler's theorem, which tells you that a to the power phi m has a remainder 1 when divided by m. Or Fermat's little theorem, which tells you that a power p is congruent to a mod p. So this concept of congruent means P is dividing A power P minus A. So A is congruent to B mod M means M divides A minus B. And Wilson's theorem, for example, tells you that a number P is a prime, P bigger than 1 is a prime if and only P plus 1 factorial plus 1 is divisible by P. And for any polynomial F, you can also talk about modulo prime. So fx to the power P power n is same as f of x P power n modulo P. So these are some basic concepts coming from modular arithmetic. And one of the important concepts is called lifting the exponents. So it tells you that if you have a prime P, so basically unfortunately, I'm not able to write on the board, so I'm just showing you the slides. So if you have a prime P and if you have A and B integers such that A, B and integers and for a prime P bigger than 2, the highest power of P dividing A n minus Bn is power of P dividing A minus B plus power of P dividing n. And when P is 2 and n is even, then you have power of 2 dividing A power n minus B power n is power of 2 dividing A minus B plus power of 2 dividing A plus B plus power of 2 dividing n minus 1. So these are kind of problems, and many times in Olympiads, there's always one, I mean the INMO or IMO, there's always one problem which says this lifting the exponent concepts. And for example, for a prime odd prime and n odd, power of P dividing A power n plus B power n is same as is equal to power of P dividing A plus B plus power of P dividing n. And and there's this Brahmagupta-Pell's equation, like x square minus dy square equal to 1 has infinitely many solutions, and d is not a square, d is a positive number which is not a square. Or Bertrand's postulate that given n and 2n, there's always a prime. These are kind of simple concepts. These are kind of results in number theory or equations which are important for Olympiads. So there's this reciprocity, and this is a bit more advanced. I'll not go into it. I just want to now also tell you about this polynomial. So a polynomial which is an like 1 plus 2x, 3x squared plus 5x plus 3. So these are kind of polynomials. So we call it of degree n. If you write an x power n plus an minus 1 x power n, etc. If the leading coefficient is leading coefficient an is non-zero, and we call it reducible if you cannot write it as product of we call it reducible if fx is gx times hx with degree of g at least 1, degree of is at least 1. For example, x squared minus 1 is x minus 1 into x plus 1, so it's reducible. And fx is called irreducible if you cannot write as product of two polynomials. For example, x squared plus 1, x cubed plus x plus 1 are irreducible. And one important fact is that any reducible polynomial of degree n has factor of degree at least n by 2. But yeah, this looks a bit advanced, but basically in Olympiads, one is asked questions about this linear, quadratic, or at most cubic. I mean, sometimes they ask, about the roots connecting to the higher degree thing. And so this is one of the important concepts on the roots of polynomial. So if p by q is a root of a polynomial, then p by q in the lowest form is a rational number root of this polynomial, then q has to divide the leading coefficient an, and p divides the constant term. In particular, a monic polynomial is the leading coefficient is 1, and any root of a monic polynomial is an integer. And a polynomial of degree n has at most n roots. And if R1, R2, Rn are n roots, then sum of the roots is minus a1 by an, and product of the roots is minus 1 to the power n naught by n. So these are kind of basic, these are basic equalities which are important for some of the problems. And all of you, of course, know quadratic equation ax squared plus bx plus c. It has roots r1 minus b plus b squared minus 4ac by 2a. and R2 minus B square minus 4AC by 2A, and sum of the roots is minus B by A, product is C by A. So many of the simple concepts connecting polynomials, they come from these roots and like sum of the roots or product of the roots. So now I will start with some very simple problems, which are kind of IOQM or RMO kind of things. And I'll go and later on show you something which are IMO level. Suppose let's look at a simple problem that you are given x and y integers, so that 2x plus 3y is divisible by 17 if and only if 9x plus 5y is divisible by 17. This is kind of a, I'll call it IOQM or RMO, simple RMO problem. So as you can see, this is very simple. Like if 17 divides 2x plus 3y, then 17 will divide 13. If you multiply anything to 2x plus 13, 3y, then 17 will divide. So if you multiply in particular with 13, you get 26 plus 39y. Now, here you can ask me why you are multiplying with 13. Basically, what we're trying to see is that you want to multiply something here so that when divided by 17, remainder becomes 9. And the same number you multiply by here, remainder becomes 5. Then you can see that, I mean, so here by trial and error, you can do it. Otherwise, you can solve some easy equations. So here, if you multiply by, say, 13 to 2 is 26, and 17 divides 26, remainder is 9, and 17 dividing 34, remainder is 5. So 17 divides 2x plus 3y if and only if 9x plus 5y. So you can also go in the other direction. This is kind of a simple divisibility kind of a problem. And another simple problem is that here you want to show that this number 21n plus 4 by 14n plus 3 is a irreducible. Irreducible means it's in the lowest form. It's a fraction in the lowest form. That means GCD of numerator and denominator is 1. So you want to show this. What we have to see the idea is that, like, if so, we're going to use the fact that GCD can be written as a linear combination of the number. So I can find two numbers. If I multiply 3 into 14n plus 3 and minus 2 times 21n plus 4, then you can get 1 as a linear combination. So that's why numerator and denominator are relatively prime or co-prime, and hence fraction is irreducible. So this is one of the simple application of these GCD concepts. Now I go to sort of sum of digits kind of thing. Suppose Sn denotes the sum of digits of n. For example, if the number is 2025, then sum of digit is 2 plus 0 plus 2 plus 5, 9. Sum of digits of 2025 is 9. So the question is that if the sum of digits of n is same as sum of digits of 2n, can you show that 9 divides n? Suppose you are given this problem, how will you do it? So the idea what we're just using is that we're using something called modular arithmetic here. Like if you take a number n, then n minus the sum of digits of n is always divisible by 9. This one can see by taking modulo 9. Write a number n in base 10, said if the digits are nt n minus 1 and so on. Now if you take modulo 9, then it becomes n naught plus n1, etc. So basically n is congruent to Sn mod 9 for any n. Hence, 2n is congruent to S of sum of digits of 2n. And we know it's equal to sum of digits of n, which is congruent to sum of n. So that means 2n is congruent to n mod 9. That means n is congruent to 0 mod 9. That is 9 divides n. So this is another simple application of modular arithmetic where you use the sum of digits. So what I want to tell you here is that in Olympiad, the ideas are pretty simple, but you cannot just one simple idea, simple identity doesn't work. You have to actually combine different ideas. Now I'll show you another problem, which is sort of simple, or you have to use a little bit different. So find all positive integers d such that d divides both n square plus 1 and n plus 1 square plus 1 for some n. So here we just use, suppose D is a number which divides both of them, you will divide the difference, which is 2n plus 1. Now D divides 2n plus 1. Now D divides n square plus 1. So and D divides n plus 1 square plus 1. So that means D will divide 4 times that number minus 2n plus 1. So somehow we sort of try to bring in some sort of algebraic manipulations to get a number without square. So then D will divide the difference, which is 4n plus 7. But D divides 2n plus 1. So you write it as 2n, 2 times 2n plus 1 plus 1 plus 5. So basically D divides the left-hand side. D divides 2n plus 1. So D has to divide 5. And fortunately, we know all the divisors of 5, 1 and 5 are the only divisors of 5. So, and of course, D can be 1 for sure. 1 will divide any number. And if you take n to be 2, then 2 square plus 1 is 5. 3 square plus 1 is 10. Both are divisible by 5. So these 1 and 5 are the only numbers which can divide both of them. So these are kind of simple RMO level problems. And this here, I want to now show you a bit more advanced, a bit more difficult. I mean, not really difficult, where you use so-called pigeonhole principle. Suppose you have this mn plus 1 numbers, integers. So you want to show that suppose m plus 1 of them, you can either find m plus 1 of them where no one divides the other, or n plus 1 where one divides the next one. You can have a sequence. Suppose you want to prove this. Then basically here you use this very simple, I mean, this idea of pigeonhole. Like for starting with AI, you look at the length of the longest sequence where every term divides the next term. And suppose Ni be the length of the longest sequence, starting at AI. And if one of the AI is bigger than N, then definitely problem is solved. In that case, we have a sequence of n plus 1 numbers where one divides the other. So assume that all the ni's are less than n. That means if you start with any AI, the at most the length and sequence. But by pigeonhole principle, if you start, I mean, see the total number is mn plus 1. So if we start with first few values, like you start with A1, now you start the next number where which is not part of this chain. Then so on, you can keep on creating chain, but every chain is at most n. By pigeonhole principle, there has to be at least m plus 1 values of AI, and this AIs correspond to sequence where none of them divides the other. So these are kind of ideas where you use pigeonhole principle. And another problem
Good
where
evening, sir.
Yeah.
Sir, in geometry, in that two-dimensional geometry or three-dimensional geometry is included here.
Yeah. Yes. So 2-dimensional, I mean, like 2-dimensional or 3-dimensional geometry are included, where about circumcenter, all these things. I mean, yeah. So the problems on
This
geometry.
is one geometry problem here.
Okay. So actually, I'll just show you I'll also show you the question paper. I'll just go briefly about this. Then I'll show you some of the IOQM paper, RMO paper, INMO paper, and IMO paper. So that will make it clear. So just maybe I'll just go a little bit. I'll just stop with here and then show you the Olympiad, the last year's papers. So suppose
Good evening, sir.
Yeah.
Thank you so much, sir, for so much of guidance and information. I want to ask, can you provide any online material for the students who are writing the Olympiads from lower classes?
No, what do you mean by lower?
Like 6th, 7th, and 8th, and so on. They all write Olympiads. So can you provide any online, links?
There's no Olympiad for 6, 7, 8. There's only one Olympiad for below class 12. I don't know of any other Olympiads for 6, 7, 8.
That is SOF maybe.
No, these are privately run Olympiads. There are many such Olympiads. I don't know about them and I don't care about them.
Okay, sir. Thank you.
So I'm just talking about the official real Olympiads. I mean, these are SOF and all these things are privately run Olympiads, and their labels are not so good. I mean, but I've been just talking about the actual Olympiads, which are recognized by the government of India, where India sends a team. This is in the Homey Center for Science Education, where if you type Olympiads, HBCSC, you'll find all the details of these Olympiads.
And sir, one more thing, that we see that questions and we see that gap between our syllabus and that question level.
Yeah.
How we able to teach the students that these things will come in Olympiad? This is very difficult to explain them.
Yeah, that's true. So, so the Olympiads are actually really targeted towards the very talented. So there should be, in the textbook, all these, you see, all these ideas, what I mentioned about remainders and GCD, they have been there always in the syllabus, but they're very basic, whatever is in the CBSE or state syllabus. So for Olympiad, actually, you need to really learn more. By the way, this Olympiad is not for every student. That's what I want to point out. This is for really very talented and very sharp student. It's kind of a divider, I will say. So it's not to be written for, not for every
We
student.
agree with what you're saying, that it is
So,
not for every student.
but the syllabus also, I think it has to be sort of,
Yeah.
they need to have prepared bit. So government or CBSE, etc., they
Yeah.
should also have a sort of a more advanced extra syllabus, including this. That I agree. So
Sir,
unfortunately,
although
After
there are very smart and intelligent children in most of the schools, most of the classes,
yeah.
they are not able to crack this exams because they are not initiated to most of the concepts discussed here. It is only in 11th or 12th, as you mentioned. But then it will not be justified if they are also put in the same pedestal as other countries. So maybe at least in the textbooks of whether it is state, CBSE, or whichever board, a mention of in the mathematics section, mention of the syllabus should be there
So
related to.
I agree. So actually, earlier times there used to be some sort of a higher mathematics course in many boards and so on. I don't know. I don't think CBSE has it now. Where in higher mathematics course they have syllabus from some of these concepts. So I think I agree. CBSE or other boards, they need to come up with one separate kind of a syllabus different from regular. So unfortunately, this cannot be taught for every student also. So there should be a separate syllabus or separate level, course for this student, or elective or something for these students who may be talented. So there one is to work out a way. So,
So
so
we
this,
won't
Yes, sir.
we won't be taking any more questions. We are already past the time. Sir, please continue.
yeah. So so these are some of the, the menus. I'll share you the slides. Maybe you can have a look at. So basically, the more, these are kind of, so if you really read the solutions, you don't need, just one single idea is not sufficient. You need more advanced, many ideas. I won't go into these proofs because the ideas, if you really work it out and see once you see the solution, you see that, oh, it's very simple or you can do it. But until you see solutions, the problems are hard. So these are kind of problems which one encounters in Olympiad. So because of paucity of time, I won't go into all this, all this, but I just want to show you this one simple looking problem 13. Or suppose you want to find all primes p such that 2 power p plus 3 power p is a power of a number. Then clearly, so if you see I'll just read out the solution. When p is 2, then 2 square plus 3 square is not a power. So p has to be some odd prime. Then when p is a odd prime, 5 always divides 2 power p plus 3 power p. So 5, and since it's a power, 5 square has to divide. Then either you can use the so this lifting the exponent or even the binomial expansion to see that p equal to 5. So p equal to 5 is it's only one of the possibility. But even if you put p equal to 5, this is not a power. So basically there are no primes such that this is actually a power. So these are kind of, so you have a solution where you can use lifting the exponent, but here you have a solution where you can expand by using binomial theorem. So of course, students need to know what is binomial or how the expansion works, how the expand or factorization works. So these are kind of things they need to get used to it. And the best way one learns or these things to solve, try looking at the solution or try to solve this problem. Only solving the problems will help. So, and also this all, solutions were used like from something called descent method. You need not worry about the method, but what I'm saying is that if there's a solution, you have a smaller solution kind of thing. And then like sometimes if you really see the solution, it's not that difficult. And this is one of the IMO problem, one of the all IMO problem where you have to use a lot of different ideas. So I just want to have, so I'm going to share this slide to you all, so that all of you can see. But these are, I just wanted to give you a flavor. Now I'll show you, I will stop this share and show you some of the earlier question papers. Let me just show you the earlier question paper. So I'll start with IOQM first. This one's. Sure. So here you can see this is the last year's IOQM paper. So I'm start like it has of course few pages. Here the students write, they can do the rough work here and you have to write answer as a 2-digit number. For example, the first few problems are very simple, which is kind of, they call it, at least students should be able to score some points. So if you look at the first problem here, find the smallest integer that doesn't divide 1, 2, 3, product of all the numbers from 1 to 9. Now clearly, so the easiest thing is says that if a number divides, then a prime number has to divide it. So now any prime less than, and if you have a number whose prime divisor is, so you can check that numbers from 1 to 10 doesn't divides this number. So 11 is the smallest number which doesn't divide. So these are simple 1-mark problem. And also like number of 4-digit odd having this exactly 1, 1, 2, 3, 4 occurring only 1, etc. Then here you have this 2 marks paper where you need to really look at some other different ideas. Like I think it may be bit, I don't know how big it is, but here you need to know the concept that if a number is less than 1, then if you look at the powers, then it's keep reducing. So this kind of concepts of this, or about this ordering of grid of points where it satisfies certain property. And like there's a geometry problem in IQM where you have a square of length 16. You have the points of CD. This usually geometry problem, it turns out that many of the students can do it because they're within, usually they're quite good with, Indian students are usually good with geometry. That's what we have seen in most of the Olympiad exams. So here, of course, you have the points on CD such that they satisfy certain property, then find the area of a triangle MAP. So these are 2 marks easy 2 marks problem. Now 3 marks and above, then problems get more difficult. And I think, so the 10, so 10 marks, like for example, like largest n less than this satisfy not is the square of any prime number. Then problems, 10-mark problems become a bit more difficult. So, and even geometry also, you have more difficulty level. So what I want to say is that in IOChem is something which most of the students should be able to, at least get some points, particularly even 9, 10 and up, where you don't really look at the very advanced ideas. You just test your ingenuity way of problem solving. Of course, some knowledge of number theory, combinatorics, geometry is important, but you don't need very advanced ideas. So this is the IOQM paper for last year. Now I want to also show you this one, the RMO. So the next level is called RMO, and I'll show you one of this RMO paper. Okay, so unfortunately, since I don't have much time, so I have to like this is the problem, of course, with the solutions. There can be many so RMO has 6 problems. So problem 1, problem 2. Like for example, problem 1 is that if n bigger than 1 is a positive integer, then you call a arrangement nice if a1 plus a2 plus ak is not divisible by k. Then prove that for n bigger than 1, there are no nice arrangement. If n is even, find a nice arrangement. So if you really see the solution, it's very simple. You don't need very advanced idea. You just need a more, your thinking ingenuity level. And RMO that way, like problem 1, 2. So these are, if you really see the I think someone is talking. Can you please switch off the mic?
Yes, sir, I have done that.
So some of this, I see, if you look at this problem, so in Olympiad, it's not about the difficulties that, you need a sort of ingenious thinking or something. It's not that if you expect to just solve it by putting some formula or just using one theorem, you're not likely to get it. So you need to sort of think, at least, for small, simple problems, you need to have 1 or 2 ideas put together. Very difficult problems, you need to have 3, 4 ideas all combined together. So like here, only the idea is that this, for example, some of the first n numbers, n into n plus 1 by 2, this side kind of concepts, and when is divisible by n, and these are basic things which are checked. So I will suggest that interested students, they should look at these earlier papers and see how they fill it and try to go to some of the basic, ideas, how it's used. So that will also give a sort of idea that if they are willing, they can work further on it. So this is RMO. So there are 6 so there can be many solutions. So like for example, problem 5, problem 4 solution, there are 2 solutions, in fact. And problem 5, there are many, it turns out that many of the problems has more than one solution. So there's not only one way, many ways to do it. So this is the RMO RMO problem. I'll just share you an InMo problem too, InMo question paper. InMo, okay, this year's. So the InMo exam was held in January this year, and this is the. So yeah, so there are 6 problems which you need to solve in 4.5 hours. So and here the problems are a bit more difficult. First one is about a sequence. So at least one, there's a sequence, then there's some combinatorics about this way of sort of a game or geometry and inequalities. So yeah, so different kinds of problems are there. So as I told you, invoice level on the base of this IOM kind of thing. So you have 6 problems, 1 from algebra, 1 from number theory, 1 from combinatorics, 1 from geometry, and 2 more from the which can be from different areas. And so here you need, in more problems a bit more difficult, where at least every problem you need at least 2 to 3 ideas, and 1 is supposed to be GS, 6 is more difficult. So it's on the lines of IMO. So now I'll show you the last one, the IMO problem for International Maths Olympiad. Okay. Just let me just share with you. So IMO problem, this is for actually last year, not this year. So there are 3 problems on the first day, problem 1, problem 2, problem 3. Okay, so yeah, so here problem 1 is supposed to be easiest, which you are supposed to solve in 4.5 hours. So 3 problems. So first one is, I mean, it can be called algebra. Second one can be called number theory. Third one is, I mean, it's in somewhere in between algebra and combinatorics. I mean, so if you really see, I mean, the solutions are also, of course, there are many resources online where you have the solutions also. And if you really see the solutions, I mean, you feel that they're not so difficult, except, of course, some of the solutions, some of the problems and solutions could be very difficult, but most of them turns out that you don't need very advanced ideas. Oh, this is the first day. Let me open the second day. Okay, I think, okay, so Olympiad problems are given as problem like separate pages. So somehow I don't have the second one. One can see it online also. So what I want to tell you, this year, out of the 6 problems, you see the 6th problem is I told you is very considered to be very difficult, and even this AI was asked to solve this. AIs could solve 6 problems, whereas there were 20 students who could solve all the problems. So basically it's all about how, I mean, so the students are trained. So why Olympiads are important is because students are trained to think. I mean, when you can solve means to solve, you need to really think different ingenious ideas. So that actually helps in many ways. So that's the importance of Olympiad, which I want to point out. So so whole idea of Olympiads is to see how much thinking or ingenious level people can have. And I mean, even if one appears for this, even if one doesn't clear or goes all the way to IMO, but training or the way you look at how the solutions or look at solving this helps you in many in your like further careers in sciences and related areas. That's what I wanted to convey. So I'll stop right now. I'll be happy to answer if you have any more questions.
Yeah, no
Good
idea,
enough,
sir.
sir.
Thank
Thank you
you.
so much.
Yeah.
Khalid, I'm audible or not?
Thank you so much for this wonderful
Khalid?
session, sir. It was really
We'll only
insightful
take
and
1 or 2
informative.
questions. I would request
Khalid,
everyone to
I am
raise their hand and we'll only
audible.
do.
Thank you so much, sir.
Khalid, I am audible or not?
Yes, sir, you're audible.
Khalid? Yes, yes, yes. So I would like to share some about that the International Mathematical Olympiad. At that time starting, I was unable to unmute my microphone. So here, some queries are about that. I'm very thankful to Professor Shanta ji, and some queries about that. There must be some syllabus beyond the class 9th and 10th. So this Olympiad is obviously it is a beyond of the regular curriculum. It is not associated with the curriculum of Indian curriculum. It is some international. There are some more steps. First step is IOQM, and then RMO, then INMO, IMTC. Stage different content like that, the permutation, combination, complex numbers. These things are be done in the training of the International Mathematical Olympiad training camp. And at the last, IMO is done. So here, during this training program, so many things, those are beyond the curriculum, our Indian curriculum, either from CBSE or ICSE or some different state board. The students, those qualify the RMO, they are trained for this such type of the content. Those are beyond the curriculum, regular curriculum.
So
And the
I
second thing,
I want to add something here. Actually, officially after IOCM, people clear IOCM, they write this RMO. Then every regional coordinators, they organize some training camp for this
yes, of
students
course.
to write RMO or INMO. So basically, they're funded completely by NBHM.
Yes, yes. Sir, after the RMO, the different regional centers are there. And at the last IM OTC, so that is the training camp is very important before the IMO. So at that stage, most of the content they will cover. And the second one thing is very important for our Indian. That is, this is the not only the second time India has won 3 gold medals at IMO. First was in 1998, and India has now been in the top 10 of the 3 consecutive years, that is 2023, 2024, and 2025. So
That's true.
gradually, most of the our Indian students they won the prestigious position at the international level, and we are in top 10 out of the 110 countries. So it's a good. I'm very thankful to Professor Shanta. Under his leadership and guidance, our India won the 7th position at the international level, 3 gold, 2 silver, and 1 bronze. And one thing is, I would like to share that the 3 students from Delhi, DPS Faridabad, the first Mr. Uh, Kankar Talwar, Kanwar Talwar, DPS Faridabad, and the second position is also from the DPS Delhi, and third from the Maharashtra, from Pune. And for the silver medal, that the Havel George Matthew, and he is also from the Bangalore, and from the bronze medal, also the DPS Faridabad, Archit Manas.
Archit Manas, yes.
Archit Manas, yes. He is also from the DPS Faridabad. So in this way, we can say that some more potency is our daily. And if our teachers and we, all educators, try to for the some if they can held some training camp at the previous level, at the regional level, then we can get our goal the best of not 10 but the top of the country, top of the international level. So thank you, sir. Over to Khalid.
Thank you, Dr. Ramesh Chandra Srivatsava, sir. So finally, we have came to an end to our 3-day webinar. Thank you everyone for being with us for all the 3 sessions of our national webinar series, Innovating Skills and Learning for Mathematics Educators. A special note of gratitude to Professor Shanta Laishram for an insightful and inspiring session on Olympiad level mathematic thinking. Your expertise and experience with the mathematical Olympiad program and guidance on cultivating mathematical thinking among students have truly enlightening. I would also like to thank all the participants for your active engagement and thoughtful questions, which have made today's session lively and meaningful. Now, there were certain queries about the certificate and also regarding the attendance. You will be receiving certificates by 6th of October in your email. Also, all the resources from all 3 sessions will be shared through your emails as a drive file. And with regard to those teachers who have missed yesterday's and day before session, first 2 sessions, we won't be sharing the attendance, but you will be able to find those sessions active in our YouTube channel, called Samka YouTube channel. You will be able to find the attendance sheets in the comment section. We'll only be keeping it for a very little time. We won't be keeping it open for all the time. So we hope the ideas and inspirations from today's session as well as from the past 2 days, will continue to enrich your teaching practices and motivate young mathematicians. Thank you once again for joining us today, and we look forward to welcome you to the future programs.
Thank you, sir.
Question.
Thank you, everyone.
Thank you,
Are
sir,
you
for
planning
attending.
on any more such sessions?
Thank you, sir. Thank you, sir.
Thank you.
Thank you, Khalid
If
sir.
you have
Thank
any
you.
queries,
Thank you,
please
sir.
raise your
Laishram
hand
sir.
regarding. Thank you so much.
Thank you very much.
Sir, attendance of first day.
Thank you, Khalid sir. Thank you, Shanta sir. Thank you, Khalid sir.
Okay, thank you. Bye-bye, everyone.
Thank you, sir.
Sir, one request is there, sir. If possible,